Um, all right, number 10. Jake, I'll take that. All right, number 10 says, what is the relationship between a stationary point and a function's extrema, or extreme values? Now, extreme values is another name for what?
Max and min.
Max or min. So it's one word that can take the place of two. So you may get a question that says, identify the function's local extrema. So what they're asking you is to identify the local maxes and identify the local mins. Okay, that's another term for that. Okay, so it's one word to describe both of them. What is the relationship? Well, first of all, what's a stationary point? When f prime is 0. A stationary point of f is when the slope, or f prime, is 0. So what connection does f prime being 0 have to f's local max and mins? That's kind of where they happen, right? Now, so it's a pretty simple question, but there's a lot going on there. What we want to say, you could have said a lot of different things that are connecting them, but the relationship is that's one of the places, that's one of the things that could be happening when f has a local max or a local min, that f prime is 0. So here's an example on 16 through 20. Right here we have this is the f graph. We have a local max right here. F prime is 0. And here we have a local min, and f prime is 0. Now it is possible to have, and I'm sorry for those people watching the video, you can't see this, but f right there, that is a local max. So I want to make sure to clear this up for everybody. That is a local max, but it's not a stationary point. Because what's the derivative here? Undefined. Now that's what was the term we had Friday? Critical point. Critical point is when the derivative is 0 or it's undefined. So, but this is still a local max. So it isn't true to say that if you have a local max, it's a stationary point. That's not true. And it's not true to say if you have a stationary point, then you have a local max. That's not true. It could be a local min or it could be neither. We talked about having a flat spot, right? That kind of a thing, where the slope is 0 and it's not a local max or a local min. So just because you have a stationary point doesn't mean you have a local max or min. And just because you have a local max or min doesn't mean you have a stationary point, but they do kind of go together in the sense that it certainly could happen at a local max or min that you have a stationary point. Or at a stationary point you have a local max or min. All right, let's talk about 16 through 20. Now several of them seem pretty easy, and then all of a sudden you got to number 19. I'm assuming number 19, that's what happened in the other class for sure. We had a huge kind of misunderstanding or confusion about that one. So let's go through it real quick, because this is the kind of stuff that today's homework is going to be about, and this is the kind of stuff that the next quiz is going to have a lot of. Okay? All right. So the first question on 16 is, at which points is f prime positive? What'd you say? A and D. Why? Tangent lines are positive. Graph is increasing. Gosh darn, I'm trying to trick you guys into saying it, and you won't say it. And what I'm talking about is the word it. I was just waiting because Doug Clark just set it up perfectly for me last period. I was waiting for somebody to say, when I ask you where is f prime positive, and you tell me at A and D, and then I say why, I was thinking somebody might say because it's increasing. We want to be very careful of the word it. It's hard not to do. It's hard not to say. I will say, and I've been doing this a long time, we want to be very specific when we're giving a reason for why something is happening, that we're specific about what function we're talking about. So on your quiz, if you're going to justify an answer, you do not want to say it is positive or it is increasing. You're going to be very careful with that. So f prime is positive here and here because f is increasing. right? When f is, because being positive and increasing are two different things, right? And so, well, we'll get to that more in 19. All right, so it said justify your answer. That's what you'd say, because f is increasing. Number 17, between which pair of points does f have a stationary point? A and B? C and D. That's where f prime would be 0. That's where the slope of f would be 0. Between A and B, between C and D. Between which two pair of points does f have an inflection point? Between B and C. Okay, so those are pretty easy because, especially the last two, they were about f. Well, the last one was about f, and that was the graph. I guess 17 was too. But here was a tricky one. 19, and it's especially tricky to explain. Between which pair of points, and I know the back probably had it, between which pair of points is f prime increasing? It is between C and D. What about between B and C? Well, the key is where is the inflection point? Between B and C. Let's assume that the inflection point is right, I don't know, where does it seem to change? Right in here, maybe? Come on. Right about there. Okay. So, Kelsey, I would not say between B and C because it's not the whole time between B and C is f prime. Oh, yeah. Okay, now let's give the reason. And I'm sure they asked, didn't they? They did. But why between C and D? What is it about f when f prime is increasing? Well, what do you mean starts at a negative? There you go. That's the key word. The slope at C is negative, because that's what f prime is, right? So we're talking about f prime increasing. So at C, the slope is negative and going towards 0 right here, which means getting less negative, right? That'd be a way to say it. And then positive and getting more positive. So what is it about the graph? Nobody said it yet. Between C and D. Concave up. That's the key. What we're looking for is a concavity. Now that's why I wouldn't say between B and C, because it's concave down until the X here, and then it's concave up after that. Now, so we had a whole longer discussion in second block about this, and I'm just wondering if there aren't some of you who are remaining silent here who might be having some of these same doubts, because the concern that people were having here was the thing that was being said in the other class. The question says, when is f prime increasing? Between which pair of points? And they felt like between the points, there weren't any points where it was increasing, because right here it increases and it decreases. See how I'm using the word it? It increases, and this is what they were telling me. Well, here it increases and it decreases. And here it decreases and it increases. And here it's decreasing the whole time. So they were saying, I can't find anywhere between any points where it's just increasing. What's wrong with what I just said there? They're just talking about f. The question is, when is f prime increasing? Right? When is f prime increasing? So what I did for them was this. I drew, oops, I can't do that from record. So what I did is, since think of it this way. When is f prime increasing? F prime means slope. So on this graph, let's just pretend we know the slope right here is -3. And then right about here, what do you suppose the slope is? -2. It's less steep. And then let's say the slope right here is -1. And then let's say the slope right here is 0. And then here the slope is 1, and here the slope is 2, and here the slope is 3. Now, let's look at those numbers. Matter of fact, let's plot those numbers. This is an F graph right here. Let's plot those numbers. We'd be over here. Let's plot a -3, and then a -2, and then a -1, and then a 0, and then a 1, and then a 2, and then a 3. What do you notice? Increasing. If this is f prime, so the question was, when is f prime increasing? Through this whole time, f prime is increasing. Now, so again, increasing is different than positive. There's two different ways that numbers can increase. They can be negative and get less negative or towards 0, or they can be positive and get more positive or away from 0. So that's important to understand. All right, it's kind of like we were talking about with speed. We say, well, if your speed is decreasing, you're slowing down. But if your velocity is decreasing, that's not slowing down. Could be, but it could be speeding up. It depends what direction you're going. So you've got to be really careful when you've got negatives and positives and you're talking about increasing and decreasing. And then, of course, the same thing is true for decreasing. Decreasing could be positive and getting less positive towards 0, or negative and getting more negative, meaning away from 0. That's decreasing. All right? I was talking, one of the homework questions, I'm just going to throw this out there right now. I was talking with somebody, and the other class was starting on the homework and had a question. It talks about where a function, a certain function, has its max value. Now think about the values a function could have and where its max would be. Let's say the function was all positive values. Where would its max be? The one that is the most positive, the one that's farthest from 0. What if the values were all negative? What would its max be? Closest to 0. The one that is the least negative would be its max, right? Those are two different ways of thinking about it. Now, if you had a function that had some positive and some negative, where would its max be? The most positive, right? So we're going to get into some of those things where we talk and we think about maxes. We have to think about those values. Again, keep in mind that f prime is a plotting. The y values of f prime are the slopes here of f. Okay, so anyway, what we just figured out here, we're going to use this here in a little bit, is when f prime is increasing, f seems to be concave up. That's what we just learned in number 19. All right, number 20. Oh, there you go. I forgot, there was this one. That's just what I was just mentioning. Between which pair of points does f prime have its minimum? Well, I was just talking about maximum. Okay, so what about a function's minimum value? It's either where, if they're all positive, the minimum would be least positive, or if they're all negative, it'd be where it's the most negative. And if it's sum of both, it'd be where it's the most negative. Well, this graph, now we're talking about f prime. Where does f prime have a minimum? Right? F prime. So we're talking about where the slopes are a minimum. Well, this graph has some positive slopes and some negative slopes. So the minimum would be most negative. So where's this graph slopes the most negative? Between B and C, at the inflection point. Now, what if you had a graph that was where the slopes were all positive? So let's say you had a graph that went up like this. Right? Let's say this was the f graph. Where is f prime at a minimum? Well, if all the slopes are positive, where's the minimum? Where it's the least positive. Where are the slopes the least positive? Well, I don't think it's a station. I meant for it not to flatten out. But wouldn't it be at the inflection point? Again, because that's where it's the least steep in that case. Now, if it flattens, yeah, it'd be a stationary point too. But again, the inflection point. So that's interesting. So where f prime is a minimum or a maximum seems to kind of correspond to an inflection point of f. So we're getting all these different connections about f and f prime. It's really important to be able to think your way through them and understand them. But we're also going to try to organize them and list them and make them easier to remember today as well. All right, so that's the homework. Let's go ahead and pull out that worksheet. And I want to talk about that a little bit. And that's more of this same thing. There's some of you, if it's coming easy to you or somewhat easy to you, that's great. You're going to be thinking as we go through this stuff that I keep saying some of the same things over and over and over again, and that's true. That's true. By the end of this week, by the time we get to our quiz, we want this to seem very simple, these connections. I told you that I thought this next quiz was a good opportunity for you to enhance your grade from maybe the last quiz. But there is one danger. I don't want to scare you off necessarily, but there is one danger on the next quiz. I don't want you to overthink it, but this quiz tends to be where you do really good or maybe down here. In other words, there's a few of these main ideas, these connections we're talking about, and if you get them, if you can make sense of them, and again, we're going to organize them and give you some really nice ways to study it, then you should do quite well. If you get off track, you tend to get off track on all of them, like you think of them backwards or something. And then that tends to not be good for a lot of the questions on there. So we'll work really hard at it. I'm going to give you some things to really help you to get those connections. So for the most part, it should be a real positive thing for you. But I guess I say it now, I tell you this because I don't think you can think through these things enough. You know, I think I told some of you on the last quiz where, like with the circle problem, I told you it'd be on there, and I think some of you worked one or worked two, and you got it, and you're like, I got it. And now all of a sudden it came to the quiz and you couldn't do it, or you messed it up. So I think it's one of these things where as the week goes on, the repetition is important to just keep going through it and going through it and going through it. And that's why you're going to hear me saying it over and over and over again. All right. So on the worksheet, let's go to the front side. The front then kind of leads into the back. First of all, you had a couple of graphs on this document where you were looking at critical points, which is when the derivatives 0 or undefined. Was it a local max, min, or neither? And then did you have some positive intervals of slope and some negative intervals of slope? So if we take a look at this first one, what's the slope in this first part here? Negative, and then after, positive. And this is a local minimum. So on your worksheet, you would have something that says that, okay, at x equals 3, why is it a critical point? Because f prime is 0. There's only two choices, either f prime 0 or f prime is undefined. It was a local min, and we had an interval where the tangent line was positive from 3 to infinity, and we had an interval where it was negative, which was before the 3. Okay? But now if we take one that wasn't a max, I don't want to do all of these, but if we go to this next one, okay, here we got one. Here's a critical point right there. Okay, I can't quite grab it, but okay, right there. That's a critical point. Why is it a critical point? Because the derivative, oops, and that was where? At x equals, help me out, 2. That's because f prime was undefined. It was neither a local max or a local min because it wasn't a peak, right? It wasn't at a peak. That's a local max or local min. Not because it was a sharp point, because it wasn't a local max or local min. Was there any place the slope was positive? The whole time. Negative infinity to infinity. Well, what's that? Yeah. Well, that's true. Technically, yes, and we should be technical about it. Because is the slope positive at 2? It's undefined at 2. So yes, we should really do that. So it's positive from negative infinity to 2, and then from 2 to infinity. Where's the tangent line negative? None. Never. Okay? Now that sums it up right there. So some of you were in B, summarize your findings. So the summary of your findings was this. On the ones where you had an interval where it was positive and an interval where it was negative, you should have either had a local min or a local max. You notice that? The times when it was neither a local min or a local max, you had none in one of these columns here. It was always just positive. See, I just did it right there. I said it. Right? You should have yelled at me right there. If I do that, yell. F prime it is positive. F prime is positive, or F prime is only negative. So if we go back to this picture here, let's go over to the next one. Okay, right there was a good example. Whoops. Right there. There's one where we don't have a local max or a local min. We have a flat spot. Now the slope is 0 there, but what is the slope to the left of 2? Negative. What's the slope after 2? Negative. There's no interval where it's positive. We don't have a local max or min. Okay, so now, go back to the worksheet. Let's go to the back side. And on the back side of the worksheet now, we investigate this just a little more. So we go to this document. Go back to our calculator document here. Going a little too fast. All right, let's go back to this doc. All right, so we go on to the next page, the next page. All right, now we have a graph with a bunch of different local maxes, local mins, a bunch of critical points. So the first one is here at -8. All right, can't. There we go. All right, so back here at -8, why is that a critical point? Slope 0, F prime is 0. Why is this a critical point? F prime's undefined. Right here, F prime 0, undefined. Right there. Ooh, right? That's a critical point, right? F prime's undefined, vertical tangent. That's a critical point. And right down here, slope is 0. So those are all the different critical points you had to fill in. Now, which ones are local maxes? -8, -2 are local maxes. So let's go back here, -8, x equals -8. Why? Because f prime is 0. At -2, it's a local max. Why is it a critical point? Undefined. So it's one of those two. They were both local maxes. Describe any change of sign. Okay, so on the table on the first page, we were talking, our summary at the bottom should have said something about when we had intervals of positive slope and negative slope, both, we had a local max or min. If it was only positive or only negative, we didn't. So now we're talking about this sign change, this moving from positive to negative. So what happened at those two places? Right here at this one. What's the slope before the critical point? After? Negative. Let's go to this one. Before? Positive slope. After? Negative. So it seems that f prime went positive to negative when f had local maxes. Now, doesn't that make sense? When f prime's positive, what is f? When f prime's positive, what is f? Increasing. When f prime's negative, f's decreasing. So if f prime goes from positive to negative, f has to go from increasing to decreasing. Isn't that a local max? This is where I do my error drawing. You have to kind of follow me. That's positive on the video. Sorry, you couldn't see it. That's a local max. That kind of makes sense. Now, at some point in this stuff, I get it if your eyes start to glaze over and it was after lunch and you're kind of half falling asleep and you're like, okay, trying to keep up with positive, negative, increasing, decreasing, right? That's why we're going to organize our thoughts here a little bit. All right, now let's go to the local minimums. Where were the local minimums? Right here? Isn't that a local minimum? What's the slope? There it's undefined, but before it, negative, after, positive. Here's a local minimum. Slope before, negative, slope after, positive. There you go. So what was that? This one? So f prime was undefined. And was it this one? F prime is 0. Those are our two local minimums. And then those two, F prime, seem to go from negative to positive. All right, which again makes sense. That means F was decreasing, then increasing. That makes a local minimum. All right, at the other two spots, oops, oh shoot. Start over. Need a few more things. Okay, right here at negative 4, what do you got? Slope is 0. That's a stationary point. What's the slope before? Slope after? Positive. No sign change. What about right here? Vertical tangent. Slope is undefined. Slope before? Negative. Slope after? Still negative. No sign change. So again, at negative 4, we had F prime was 0. At 1, we had undefined. Okay, because of the vertical tangent, we had neither. This was a flat spot right here. This was a vertical tangent, but it's not a local max or a local min. And we had no sign change. One was positive and then stayed positive. One was negative, the slope now, F prime was negative, stayed negative. So this sign change seems to tell us if we have a local min or a local max. That is called the first derivative test. All right? Tells us when we have a stationary point or a critical point, if that is a local max or a local min. All right, that's a lot of stuff. So what we want to do next is we want to make a list of all this stuff, an organized list of what we have just been talking about. So let's put this in our notes. We're going to do 2 bits of organization today. One, we're going to make a list, and then we're going to organize that even better. All right, so let's summarize what we have found from our homework today on 16 through 20, that discussion we had there, and then this worksheet that we did. Let's summarize our connections. So we're going to start by discussing F prime. So, and then tell us what that says about F. Now we could work it both ways, but we'll go this direction. So what are some of the things we said about F prime? F prime could be what? F prime could be positive. Let's don't write that down here. Let's just think through them, then we'll organize. F prime could be positive, negative, 0, undefined. Keep going. Number 19, right? F prime could be increasing. F prime could be decreasing. I think that pretty much summarizes what we've said about F prime, I think. Right? So let's do it. So let's start with F prime equals 0. That's our first option. If F prime equals 0, F is a stationary point. Now, it could be a local max, right? Local min, or neither. We said neither. Let's call it a flat spot right now because that's really the only other option if F prime is 0. Now, off to the side here, let's put that F prime could also be undefined, which would include then critical point. And again, if F prime is undefined, it could be local max, local min, or it could be a sharp point, or it could be a vertical tangent. Now, the only reason I'm not going to throw that in there right now, really as a big emphasis, is we're probably not going to have any of that necessarily. Well, I won't promise it won't be on the next quiz, but it certainly won't be a big emphasis. But yeah, we need to understand that a vertical tangent, slope's undefined, at a sharp point, slope's undefined. many of the functions we'll work with in the beginning parts here of calculus are going to be nice, smooth graphs that don't have these sharp points and vertical tangents and stuff. Those are usually pretty easy to spot. So we're going to focus more on just derivative being 0 for right now. Okay? So just kind of put that out there as another option as well. All right, number 2. F prime could be positive. Let's just say, we'll do some abbreviation here. I mean, we could do F prime greater than 0. That'd be more mathematically correct. Okay, but for right now, we'll just talk about F prime being positive. If that's true, then F is increasing. We'll just draw an up arrow like so. F prime is positive, F is increasing. And if F prime is negative, F is decreasing, right? Now, let's stop right there for a second. Let's talk about this a little bit. Most of what we deal with is going to be graphs here in the early going through this next quiz. The next quiz will be a lot about graphs and not necessarily equations. On your homework today, there's going to be a few equations. They're going to give you an F prime equation. Just get your calculator out, graph it, and then sketch that, and then go from there. So we're really looking at these as graphs right now. So let's talk about what it means for F prime to be positive. If I have an F prime graph, okay, and let's just do something like this. Let's call this point A, point B, point C, and we'll say that this is also the inflection point right there at C. Point E. Okay, if that's an F prime graph, tell me where F prime is positive. In what intervals? From where to where? From A to C, this is F prime, right? This is F prime. See what I'm talking about? When I was talking about the quiz, if you get off track, right, where you could, because this is one of those things where we're going to have a question, it's going to have like A through F parts. And if it's the F, yeah, I know, and that's where we've got to really be careful. So this is the F prime graph. If you get to thinking in your head it's the F graph, and you answer all your questions accordingly, they're all going to be wrong. Now, I hate doing that, but there's not a really good, there's no really good way to do it. You've just got to know. You've got to pay attention to that. You've got to be careful. And I'll remind you, hey, double check. Remember, this is F prime, this is F, right? I mean, I'll try to help you. This is the F prime graph. So let me say it again. Where is F prime positive? From A to C, and from E onward, at least what we can see. Yes?
Will there be any of the F2 primes?
Yes. We'll be getting into those tomorrow. Yes. So, F prime is positive when it's above, now I said it there, but I followed it right after I said F prime, so that is okay. F prime is positive when it's above the x-axis, because what we're talking about when we talk about F increasing and F being positive and all this stuff, we're talking about its y values. We're talking about its y values. So we talk about F prime, where is it positive? We're talking about where the y value is positive, which means above the x-axis. So likewise, where is F prime negative in this one?
Below B.
From C to E and before A. F prime is negative. Okay. So where's F prime 0? At A, C, and E. F prime is 0 at A, C, and E. Okay? All right. Now, see what I did? That's now the F graph. Where's F prime positive? From A to B, from D to E and passed on, okay, onward. Where is f prime 0 at B and D, right? So see the difference. Now, you're going to have some of both of those. We're going to have some problems. There'll be some problems on the quiz where, and same on the homework today, where they give you an F graph and they ask you questions. And there's going to be some where they give you an F prime graph and they ask you questions. And so you've really got to make sure which one are you looking at and what is the question asking for. Okay? Very important. One more on this one. Where is F prime decreasing? A to C. That's like number 19. F prime decreasing would be when F is concave down, because these slopes are, like say the slope there is 4, and then 3, and then 2, and then 1, and then 0. So F prime is decreasing, positive and getting less positive. Then the slope is -1, -2, -3. Negative but getting more negative. Again, that is a decrease in F prime. So F prime is decreasing from A to C. All right, but we actually haven't gotten to that in our list of connections yet. So, but I just wanted to throw that out there. Okay, so back to this. Number 4. Let's do what we learned on the worksheet now. Since we just got into talking about when F prime is positive or negative, let's talk about the sign change. So let's say this, when F prime switches from positive to negative, what's F do? Well, yes, you're jumping ahead of me though. We want to say F switches, there we go, increasing to decreasing. So F has local max. And then I also want to call this number 4. We're going to have 2 lines on number 4 because now we got the vice versa, but it matters. If F prime switches from negative to positive, F switches decreasing to increasing. That's a tip. So F has local min. Number 4 is the first derivative test that we just learned on our worksheet. Okay? Now, that is a very common question on the AP test. Identify local extrema. Identify local max or min, and then they'll want you to justify why it's a local max or min. This is what you write right here. You say it is a local max or something similar to this. It is a local max because F prime switches from positive to negative, so F switches from increasing to decreasing. You have to have both of those. As a matter of fact, in the course description, and I'll show you later, in the course description that I handed out to you, they're very specific about what they want you to say in that question. It's such an important question. They want you to have both parts. You can't say, they actually used to be able to, 5 years ago on the AP test, you could say it's a local max because F prime goes from positive to negative. That's all you had to say. They changed it because they wanted to make sure people understood the connection between F prime and F. So you've got to say both parts of that. And I will remind you that many, many times over the course of the year. All right, number 5. What else do we say F prime could be? F prime could be increasing. When that happens, F is, right? That's what number, the one we just talked about was, right? If F prime is increasing, that's what number 19 was. When F prime is increasing, F is concave up. Number 6, F prime is decreasing. F is concave down. Okay. Number 7. Let's talk about the switching of those two. Right? Let's talk about the switching of those two. That's the last thing. We hadn't really talked about that. What happens if f prime switches from increasing to decreasing? Now let's think about what the f prime graph would look like. If the f prime graph increases then decreases, that's a local max on f prime. That's different than what we were saying earlier. We were talking about local max of f. If f prime has a local max, f what? It's got to be an inflection point, because look what's happening. If f prime switches from increasing to decreasing, f switches concave up to concave down. So f has an inflection point, because that's what an inflection point is, when f switches concavity. Now, what happens if it switches the other way? Yeah, we'll just put vice versa. The direction on this one doesn't matter. Now on 4, the first derivative test, it did matter. Because if you switch one way, you've got a local max. If you switch the other way, you've got a local min. So that matters. But with the inflection point, it doesn't matter. If concavity switches either direction, you have an inflection point. So if f prime goes increasing to decreasing, or if f prime goes decreasing to increasing, then you've got an inflection point. Okay, there's a lot of stuff that we're going to actually reorganize this even in a little more compact way later, but this is pretty good. This has all of that stuff that we've talked about contained in it right there. Okay, here's the next thing we're going to do. I'm going to have you get into groups of 2 or 3. No more than 3. And I would like you to at least be in with a partner. I don't have enough cards for everybody to do it themselves. This kind of, I know Mrs. Payne had some matching activities for you last year where you did these kind of things. This is what we're going to do with this. Now, we're really only probably going to have time to fill in the second column. Okay? And I'll show you what I mean. So here's a set of cards. I only have 9 of these. Like I said, I think we have enough for everybody to pretty much do groups of 2. Groups of 2 would be better than groups of 3, but it's up to you. Oh, shoot. Here's somebody who didn't do a very good job of organizing this. Dang it. All right. Well, you'll just have to organize them when you get them. But I want to, let me see if I got one here that did a decent job. Okay, yes, here we go. So, we've got some cards here. That have graphs on them. Now these cards, this stack of cards, see the capital D, D for derivative. So these would be like the F prime cards. Okay? And these cards have F on them, that's like the F graph. So we got F and then its derivative, or F and F prime. We're going to match those two graphs together. Now, there's 2 ways you can do it. You can look at the F graph and think of what the F prime graph would look like. Or you can look at the F prime graphs and think about what the F graph would look like. You really need to be able to do it both ways. Matter of fact, if you want to do half of them one way and half the other, that's okay. All right? But it doesn't matter to me. But we have to be able to think through it. Now remember, the F prime graph, the Y values, are the slopes of the F graph. That's the key. So we're going to match these. Now the other cards are descriptions. I don't care, only if you get done and nobody else is finished yet, you could go through these. So the little d is a description of the derivative graph, and the little f is a description of the f graph, and you can match those if you want. But you don't need to. You only really need to work on matching the graphs. And I will have these available throughout the week if you want to practice them again. It is a good way to really think and quiz yourself on these descriptions. Okay, get yourself into groups of 2 or 3. Each group needs a packet of cards. And fill out the second column so you match your derivative and your function graphs. We're only going to take about 15 minutes for this, okay? So we want to be done by 20 after. I'll leave this. I'll leave this up on the board if you want to look at it. Of the connections that we've just written. Okay. Okay, if you're watching the video, there's going to be about a 15-minute blank spot here, so you can fast forward. I'll come around here a little bit and check your progress, see if you got which ones you have right or wrong, whatever.
First.
So it was good for a while. But it's not now. But it would help.
Wait, is this D2? Because, you know, if it says that increasing stuff has a
Now make sure you communicate, make sure everybody in the group is getting it, and if not, ask. Make sure you explain it to each other. So, maxima isn't extreme, maximum. Right, max is a little max.
Now, is everybody agreeing?
zero.
You guys got some answers? Those are that one is those. Let me tell you what I just these Y values are these slopes, right? So positive at first, graph goes up at first, then negative until there, Graph should go down until there, and it keeps going down. Back when this goes back to positive. So it should go. Yeah. Does that make sense? Okay. That is right. That is right. That is right. That one is not. That one is not. Well, look at this one. It starts positive, so it starts going up. Then it's negative, stays negative this whole time. So this one would have to be going down. This one's right now. So
Yeah.
Then it's negative and stays negative.
those first two.
What are you looking at first, the F? That's concave down, which tells you derivative has to increase. A decrease. Concave down is decrease. So where this one is concave down, you're looking for a graph that is increasing. If the F graph, look at your thing, the F graph is concave down. F is concave down. So F is concave down, which is this one. So you're looking for this graph. Until it's equivalent to concave down. Increase. So you're looking for going down, then going up. I'll be honest, I use it caveat. If I'm trying to find it, I'm looking for slope. So slope is positive, and it's negative, and it's positive. positive, negative, positive, negative. So when you rip the graph, above the x-axis, then below, then above, then below. So I'm looking for a D graph above, below, above, below. Match one.
Okay, or you're writing them down, or you're just writing?
Oh, yeah, yeah, no, okay, so positive, so.
Okay, we're just another minute or so here. You got to think of one thing, the concavity talking about the increase to me is the slope is easy. The slope is there's a lot of connections, just pick one and go with it. All right.
Yeah, I think you're right.
Okay, let's stop there. I know some of you didn't quite get through all of them. I will have these available if you want to check them out, take them home, go through them. It's a good way to practice these connections. If you would put them back together for me, put all the D graphs together, put all the F graphs together, all the D descriptions, all the F descriptions, mix them up a little bit, but keep them in those four groupings, D graphs together, F graphs together. Put the little clip on it and put it back up here on my desk. I'd appreciate it. We got several things we need to go through yet before we're done, so let's do that quickly here. And then move the desk back if you would, and we've got a couple other little activities, not activities, but things to talk about here. Thank you. You. Okay, did I get them all? All right. All right. So that's a good way to think, and we were having a conversation up here. There's so many connections in this list that are all there, but you don't need to use them all, right? I mean, just pick out one. Like for example, the first 1, 2, or 3. Those are the key ones. You know, where's the derivative? Wherever the F graph is going up, the F prime graph should be above the x-axis, positive. And where the F graph is going down, the F prime graph should be negative or below the x-axis. As a matter of fact, Here's another thing I want you to see graphically. The first derivative test graphically would look like this. If I have an f prime graph and it goes like that, I know a whole lot about the f graph right there. First of all, this is a really important point right here. Why? The slope f prime is 0. That is the first thing in our list, right? That is a stationary point. So when you have an f prime graph, looking at the x-axis is a key spot. That's a stationary point. And in number 4 in our list of connections says when f prime switches from positive to negative. Well, isn't that what's happening right there? Isn't f prime switching from a positive y value to a negative y value? Absolutely. So what do you have on your f graph right here? A local max. And if this graph were to continue and maybe do this, what you have is f prime switching from negative to positive, which was what we said makes f have a local minimum. And then finally, if you had an f prime graph that did this and bounced, let's say, what do you got? Well, yes, but that talks about concavity. Flat spot. In other words, we have f prime is 0, which means the slope is 0, but what happened there is f prime didn't change sign. F prime was positive and stayed positive. That means the f graph was going up, flattened, and then kept going up. That's a flat spot. Positive and stayed positive, right? So those are the things you start to look for. So if we got those cards out again after going through this, and that's what I'm saying, if you would want to check them out one night and take them home and look at them again, you start looking for those kind of things as well. You might look at your f prime graphs and you would look for those places where it was crossing the x-axis. And the way it crosses the x-axis is important because that gets into this number 4, which is when f prime switches positive to negative or negative to positive. Okay, what I want to do next is I want to take this, so everybody have this list of connections out in front of you, and I want to take this and I want to summarize it even more. And what we're going to do is we're going to create something that I have, over the years, lovingly named the chart. The chart. So if you ask a former calculus student about the chart, they probably, well, I hope they could probably even recreate it for you. Depends how long they've been out of school. But here's the chart. Now the chart is going to be something that you will be able to recreate at a moment's notice. As a matter of fact, on Thursday's quiz, probably the first thing that will happen when I pass out the quiz before you even put your name on your paper is you will draw the chart. Okay? At least I would recommend that maybe you do that. The chart has 3 rows. It'll have 5 to 7 columns depending when we get finished here. Should have made some of those cells a little bigger so I could have a little more room to write. But, all right, the first row is going to be F. The second row is going to be F prime. And the third row we'll talk about tomorrow. But for right now, we'll do these first 2 rows. So, connection number 1 in our list was what? F prime is 0. F is I'm going to write SP there for stationary point, and that could be a local max. See what I mean? I should have made this a little bigger. Local min or flat spot. Now later on we'll talk about what happens if f prime is undefined. Okay? And this won't be the last time you draw your chart, so you want to make a great big page, fill the page chart, that's fine. But one of the things you might do between now and the quiz is practice drawing the chart from memory. It's pretty easy to do. What was number 2? If f prime is positive, f is increasing. If f prime is negative, f is decreasing. Now, number 4 said if we switch. So what I would do is I would just draw some arrows showing a switching of columns. In other words, the first derivative test is if we switch columns. So if f prime goes from positive to negative, then f goes from up to down. If f goes up to down, that's a local max. If you switch columns where f prime goes negative to positive, then f goes down to up. Down to up is a local min. So you just, to do the first derivative test, the local max, local min thing is just a switching of those two columns. Okay? What was number 5? If f prime is increasing, f is concave up. If f prime is decreasing, f is concave down. And number 7 then was what happens if we switch those columns? We have an inflection point on f. So there you go. That little chart pretty much capsulizes everything that we have been talking about and organizes it, I think, in a reproducible way so that you can, and the key is that middle row. If you can just remember f prime, what can it be? It can be 0, it can be positive, it can be negative, it can increase, it can decrease. And then what does that mean? And it's just pretty easy. There's just not a lot there when you really think about it. Keeping it all straight is good, but if you kind of memorize this and have it down on your quiz, and if you kind of get stuck on some of those things, you've got that in front of you. I think it's a good way to organize information. Okay? At some point as we go through the year, you won't even need really to have it in front of you. You'll just have it from memory because we use it so much. So much. We will add a few things to it tomorrow. We'll talk about f double prime, throw that in there, and so forth. Okay? All right. The last question I want to talk about is this right here. So if you would sketch this in your notes maybe, just doesn't have to be real fancy. I think if you just plot those black points that I have there and then connect them real quickly here, doesn't have to be real fancy. But one of the things you're going to do in your homework today is they're going to give you an F graph and ask you questions about f prime, and they might even ask you to sketch the f prime graph. So it's kind of like that matching thing you did, except you would actually just sketch the f prime graph. And it can be somewhat rough. It doesn't have to be perfect. There'll be certain aspects it'll have to have correct. And then the other way around, like this problem, where we give you the f prime graph, ask you questions about f, and maybe ask you to sketch the f graph. Okay? So be able to do that both ways. And that's like what we were talking about earlier, is you want to make sure you're thinking of it the right direction. Or you could have everything being backwards. All right. So, give you a second to finish sketching that. Now, while you're doing that, I was going to we're not going to have time probably. There's a couple of your homework questions where they give you, instead of graphs, they give you equations. Now, everything we've done here is about graphs. The quiz is really pretty much going to be about graphs. But if I gave you a problem and said f, don't write this down, but if I gave you a problem and said f prime was equal to x plus 2, and then ask you a bunch of questions about f, just graph it. Get on your calculator. Now, hopefully you don't have to get on your calculator to graph this one. But x plus 2 would just be this graph right here. Right? Cross at -2. Just graph it and then go from there. Okay? So we were gonna do that, a problem like that, but it's pretty easy. It just fits in with what we're doing. But if they give you an equation for f prime, just graph it and then go from there. All right. So here we go. So I'm going to do this in blue. So what should if I want to draw the f graph right now, what am I focusing on this graph? So where would those be? So I might really take a good look at those points right there. Because what's going to happen on the graph I'm going to be drawing? That's where the slopes will be 0, which would be max, mins, or flat spots, right? Now I can actually tell what they're going to be because this one, it's what we just talked about. That one goes from negative to positive. What's that going to be? That's going to be a local min. This one's going to be a flat spot. That's going to be max. Now if you're looking at that saying, oh boy, I don't see that because I can see what your eyes might glaze over a little bit. You don't need to know that, but those are all these connections, kind of like we were talking up here. There's so many connections, you don't need to see all of them. Just see enough. Now, that wasn't exactly what I was getting at, though. The first thing we talked about with f and f prime, I told you this, is what? On the f prime graph, the y values are the slopes of f. So if I have the f prime graph, what I would suggest is you focus in on the y values and then think of those as the slopes of what you're trying to draw. So I'm going to start here and notice that the y value is -2. So the graph I'm about to start drawing is going to start by doing what? Going down with a slope of about -2. Now the question is, where do I draw? Actually, it doesn't matter. Yeah, it doesn't matter. I'm going to start it right here, right in here, whatever. Doesn't matter. So I'm going to start my graph going down like this. Now, let's move to the right and keep looking at our y values. Now, what are the y values doing? Getting closer to 0, which means my graph is flattening, getting less negative slope, whatever. So it's coming down like so, and it's going to flatten like right there. Right? Now, I don't know how far down it goes, right? I just know it's coming down, negative but less negative slope, and it's flattening, and right there we said we should have a local min. Now what are the y values doing? Positive and getting more positive until there. So that means my graph's going to do what? Go up, 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 steeper and steeper until there. Inflection point, that's right. Because now what are the y values on the f graph after this? Well, yeah, but then that confuses it. Let's just talk positive. Positive, but less positive. So that means this graph is doing what? Still going up, but flattening, right? Not as fast. Flattening, because didn't we say this has a slope of 0 right here? So it's got to flatten there. Now what are the y values on the black graph doing? Okay, let's don't say increasing, decreasing, that confuses it. Still positive and getting more positive. So that means these slopes I'm about to draw are going up and steeper until there. Right? Now what are the y values on the f graph? Still positive, right? They're positive the whole time, which means my f graph's doing what? My blue graph's doing what the whole time? The blue graph, by the way, is f. Still going up, but they're positive and getting less positive, which means they're flattening. It's flattening until there. So that point corresponds to that 9. Then what? Finally, the y values are negative and getting more negative, which means my graph will start to go down until there. Right? That blue graph should be the f graph to that black graph. Now remember we said we didn't know where to start that blue graph? Imagine this blue graph shifted up. Wouldn't it still have all the same slopes? So now that's kind of interesting. That means an f prime graph could have an infinite number of f graphs that would match it. They would all be vertical shifts of one another. Right? Because all these y values tell us is the slopes of the f graph, which is the shape of the f graph. But if I shift this graph up, shift it down, I don't change any of its slopes. So this one f prime graph would have an infinite number of f graphs that go with it. Now the other way isn't true. One f graph would have only one f prime graph that would go with it, because it has only one set of slopes. Okay, but you could have a bunch of f graphs that would all have the same f prime graph if they were all just vertical shifts of one another. Okay, so we want to be able to go both directions with that. Now it's easier actually to go the other way. If you have an f graph and have to draw f prime, that's easier, because all you have to do is look at these slopes and plot them. Say, oh, this slope's about -2, about -1, about 1, or -1, oh, 0, and you just plot them. So it's a little easier to go that way. Going from f prime to f is a little tricky. All right, so here's your homework. It's a little different than what's on your sheet. We're going to do 1.6. Okay, this is going to be in section 1.6. We're going to do 21 through 36. And then we're going to do 46, 50, and 51. Now 21 through 36 are very much like what we've been talking about. Here's an f graph. Where's f increasing? Where's f decreasing? Not a lot of work to show. It's going to be a lot about doing these intervals. It's increasing from here to here. F prime is positive from here to here. F's concave up from here to here. Right? Identifying those things. So using your chart, get practiced. So for most of the homework, you want to have that chart in front of you, reading off of that, using these connections.